So we heard two very compelling transformation stories that happened. Now we're going to change your perspective a little bit to talk about a transformation to come. And the question is, when you're on the top of your game and top of your market or your domain, what do you do next? What is the perspective that you take? How do you try to keep that advantage or widen it? Our next speaker is leading this initiative for the most successful Formula One team in the current era. And I'm very excited to have him on stage. He flew in just for us and is going to fly back for other obligations, so I want to thank him personally for the commitment and coming to talk to all of you and share his perspective on the role that innovation can do on the performance of the team. So ladies and gentlemen, please join me in welcoming on stage the Technical Director of Mercedes-AMG Petronas F1, Geoff Willis. Geoff, welcome.
Thanks very much.
Thanks.
Well, thank you very much, Thomas. Thank you all for the opportunity to share a little bit of our business and our work in Formula One. I should start off with a little bit of an explanation. My slightly strange job title, Director, Digital Engineering Transformation. Our Digital Engineering Transformation Group we set up about a year ago or so as a function quite distinct from IT. And it was really there to give an engineering focus on all of the digital systems that underpin the engineering functions of our business. And the title's a little clumsy, but it was chosen to really highlight that digital transformation is going to be integral to the further development of our engineering processes. Now, I come from a background of 30 years on the more technical side of Formula One, aerodynamicist, chief aerodynamicist, technical director, etc. And so I'm very much new to this world of information and digital technology. But the fact that we are investing and we believe we need to commit to this digital transformation, I think is a sign that even for a business of Formula One that is absolutely founded on data and has made huge investments in digital technology, even we're beginning to realize that we need to do more with the data and the technology we've got, and we need to transform ourselves to put ourselves in the position to take on that new technology. We're not digitally transformed yet at all. In fact, F1 has made huge digital investments in the last 5 to 10 years, and we're moving much more in towards the virtual world of design and development. But we're still not very integrated. We're still not seamless. So, cut to the chase. What's the objective? Our objective, the team's objective, is very simple. We want to win world championships, plural. Sorry, Emiliano. So our mission, the group's mission, is to ensure the team has access to the most appropriate digital engineering tools and identify and implement new technologies. And our vision is that we will have an optimally integrated, a seamless, intuitive, secure, and effective set of digital systems and the ability to recognize and to quickly realize a competitive advantage from new technology. So, try again. We'll move on. I'm failing. Right. So, many of you, particularly in North America, will be not so familiar with Formula One. It's a global sport. It's probably, in terms of global sports, it's the third largest after Olympics and World Cup. And we've got 10 teams racing in 21 races in 21 countries over 9 months of the year. It's the pinnacle of motorsport, both in terms of its technology, and it's also unique because the teams themselves are required to design, develop, and construct their own race cars. And this is quite unusual because it means that we can't buy this technology from anybody else. The team itself, AMG Petronas, my team, is about 900 of us in Brackley in the UK, and there's another 600 engineers and technicians at Mercedes High Performance Powertrains who produce the power units for ourselves and which we supply to customer teams. The pace of competition and regulation changes that govern our sport means we're being forced. Oops, here we go. We're being forced into multiple regimes of performance development. We have to deal with a week-to-week, the race-by-race performance development. We're having to deal with a month-by-month development because the design of the cars and the power units are not static. develop throughout the year. In fact, the pace of development is such that the top teams develop by something more than half the difference between the top teams and the bottom teams in a given year. And we're having problems because the presentation's moving forwards too fast. And the problem is that we can start the season with the fastest car, and if we don't develop it, we'll struggle to be mid-grid by the end of that season. So we're under pressure. These 3 cycles, week by week, month by month, year by year. But we talk about performance a lot, and we're in a position where we get to see our performance very immediately. Every 2 weeks, we get challenged on our performance level. And sometimes that's quite blunt. And this year we had 6 races in 7 weekends, so that's relentless. But performance is really the end of a chain of activity. The performance is really a reflection on our capability. And today's performance is a reflection on yesterday's capability. And tomorrow's performance is going to be a reflection on today and tomorrow's capability. So the real race is not performance. The real race is capability development. So I started, nearly 3 decades ago in Formula One, and that's coincided with the early days of digital data. And we started off with a few dozen channels of data from the car, and that's evolved to literally thousands of channels of data now. And we're recording everything on the car. We're recording all aspects of the chassis, the engine, and the driver. And we measure everything: displacements, speeds, accelerations, forces, temperatures, pressures, control parameters, and of course driver inputs. And if we add the video data and the thermal image data we take from the tires, that's now about 0.5 terabyte of data every race weekend. We also have had to deal with the fact we've had a number of initiatives from the governing body, the FIA, that control motorsport, to try and control costs. And some of these initiatives have resulted in really very severe restrictions on the amount of real-world track testing we can do, and also restrictions on certain types of testing we can do in the factory. And as well, in an event to reduce consumption, we got limits on the numbers of race engines and gearboxes we can use, and we also have much more extensive use of what's called parc fermé, where literally it's a closed event at the race weekend. We're not allowed to touch the car. So we've got a number of challenges. We need to deal with the performance challenge all the time. We've got less testing, almost no testing compared with 20 years ago. We've got fewer resources to do it, and we've got to make all these things more reliable. So we're big pressure. This has driven all of the teams to invest a lot more in rigs in the factory to replicate track conditions, to test all their components in circumstances in a controlled environment that replicates the race world. We've also had to back this up with a huge amount of additional simulation tools. Those simulation tools involving software in the loop, hardware in the loop, driver in the loop. And we inquire now, I think in total, from all of these rigs, from the dynos, from the wind tunnel that we use, from all the systems rigs, we're acquiring more car data now off the car than we ever acquire on the car. The digital data generation has grown as well. So when I talk about this is data coming purely from simulation, but especially what we, in our aerodynamic development, computation fluid dynamics, CFD, and in the simulation tools. And as well as supporting the design and development of the cars, we're using all these simulation tools to prepare ourselves for each individual track. So we use these extensively to get the car optimized, it's set up, ready for the track. This allows us to go to the track, and then our main challenge is dealing with the local, the subtleties of how the tires affect the car in the conditions of the racetrack. So a final segment of data, which is new to us, is in optimization. And optimization is this next level above simulation. It's establishing the design trade-offs between all of the different conflicting parts, the aerodynamic, the power unit, the packaging, the tires, and using new technologies like generative design for structures, and these things that grow, these very much more organic geometry solutions. So in total, we're generating between sort of 5 and 10 terabytes of data a week. It's not big data, we're not in the Google, the Amazon, the Apple world, but we've got a lot of data, and it's a major challenge to manage that data for us, but it gives us many, many opportunities, and those are the opportunities that we're just starting to explore. So, a Formula One car, it's a car, isn't it? Well, actually, it's a car that really shares most of its technology with the aerospace sector, and we use a lot of aerospace tools, CAD, CAE, computer-aided engineering, and computer-aided manufacturing tools. The design task is quite simple to outline, but it's complex in solution. So our mission is we need to produce the fastest car over a race season. This means across a whole lot of different circuits, balancing their different demands on performance, and maintaining reliability across that season. And the optimum car is not necessarily going to be the best at every circuit. There will be circuits we go to knowingly that we're not going to be the best car. But the focus is that season level. Regulations control a lot of what we can do. We have a limited fuel formula, and we have single tires supplied by a single manufacturer that's common between all the teams. And we have a strict set of technical regulations that limit how much we can do with power unit design, with the chassis shape, with the aerodynamic devices. So the reason that it's so complex is because the nature of interaction between all the components. In particularly, the new generation of power units, we've got these V6 turbo hybrids with electric motors and battery system in them. They've triggered a whole extra degree of complexity because the optimum performance, the optimum selection of all of those components is actually dependent on car performance. So you have to, before you even have the car and know how its performance characteristics are, you're already trying to design the optimum parts of the power unit. And some very counterintuitive things happen. It turns out in a limited fuel formula that a faster car actually uses less fuel. Can explain later. So we have to balance the aerodynamic downforce. This is the thing that gives us the fantastic grip that allows us our 5G corners and 5G braking. We've got to balance that with the cooling demands of the power unit, the characteristics of the power unit. We've got to design the suspension to support the characteristics of the aerodynamics and also to look after the tires, which are the hideously complex things. These are things very sensitive to their thermal properties. They're very complex thermomechanical devices. Typically, on the side, they're running at about 120 degrees centigrade, and they have to be kept in a 10-degree window for their optimum performance. The problem is, through a single corner, they can change by 40 degrees centigrade. So you can see what we're up against. So the old days of trial and error are long gone. And the key to design success for us is really understanding the physics of the race car, and, most importantly, correlating and validating our simulation models with our real-world data. So, we have to take a system-level view of design, and we have to look at the total performance consequence of our design decisions. And we've developed lots of optimization tools to help narrow the field of where we should be searching. We're using a lot of nonlinear optimization control algorithms. The concurrent nature of our design and this complexity really stresses the need for communication and data sharing within the organization. The new car program follows a clear plan, and we start off with a concept, with the aerodynamic concept, major components, power unit, transmission coming in, and then the detailed design follows, getting ready for production. But we need to be very flexible at all stages because, remember, we're running these multiple cycles of development, and we're learning all the time. So we have to be able to react to that new learning. We have to get back into that plan and change an awful lot. But of course, design and development is just the first step on the chain, and manufacturing is a major challenge. And we have to we do a lot of manufacture in-house, the majority of manufacture in-house, for two reasons, both the technology and also the controlling the time, because time is critical to us. We're using a lot of new technology, numerically controlled milling, additive layer manufacture, 3D printing. And all of this depends on a big system of software tools, PLM tools, product lifecycle management tools, which we use from Dassault Systems, enterprise resource planning tools, we're using SAP. So we have to be very, very integrated in all of this. Now, it's easy to imagine that Formula One is this sort of top-down level organization, you know, the leadership set the target and we're all marching off in the same direction, that plan. But our experience has really shown us quite the opposite, is that we need an environment that allows freedom at many, many levels to make decisions and to take risks and to take appropriate risk. So it's much more important for us as leaders to define the intent and cascade that intent down and allow local decisions. We have to give people their local intent and we have to give them their constraints and their resources, but we need to give them the freedom to make decisions, take risks, and the freedom to innovate. We do set clear objectives and we do track key indicators, a few key indicators. We have a complex performance tracker that predicts the performance of the car from all the different components, aerodynamic, power unit, tires, whatever we've discovered and learning through the process. We have trackers on the car weight we have to design down to a minimum weight, and we have a tracker on the release of designs for manufacture, on the progress of manufacture, and all of those trackers are available to everybody. So everybody is able to make a decision in the context of are we meeting our key indicators. So program planning is very, very important to us. You know, we have to be on time. You know, the race starts at 2 o'clock on a Sunday afternoon. Not much good if we're there at 1 minute past 2. And similarly, we know, not sure exactly now, we know we're going to launch a car on the 17th of February next year. That car will be there, absolutely will be there. At 9 o'clock in the morning, we will start the engine, it will be on the track. In order to do that, we have to have very detailed program planning, but we also need the flexibility. We have to deal with the unexpected. Like any organization that's pushing the limits of its own capability, we're going to run into problems. And our solution is to try and predict as many of those problems, to have the flexibility, to have the backup plans. But of course, we do need a very flexible workforce. So, I'm often asked, where does the success of the Mercedes, where does the success of the Silver Arrows come from? And of course, the skill of our workforce, our support, the resources we get from Daimler, our parent company, and our sponsors and partners like TIBCO is absolutely crucial. But more important than that is, I think we've taken, or as important, we've taken a slightly unusual view of performance. And performance we've taken as a specialist subject in itself. And we have a performance group who are there to take a very objective, rational look at our competitive performance against our competitors, using objective data assessment, not to find solutions, but their job is to identify the key performance differentiators and help us set the priorities for where we should be looking. My experience, engineers, it's probably true of all of us, we like solving problems. Our usual mistake is we solve the first interesting problem we find. We don't necessarily choose the right problem. So the point of having this separate performance group owning performance as a concept is that they set the priorities. We can then unleash the full resources of the organization on solving the problem. Now, I've talked several times about risk. I need to expand a little bit on the concept of risk. Obviously, when we get to the track, when we go racing, we're risk averse, and we have very strong protocols for dealing with making sure everything's signed off, tested, and we just don't change. We don't, if it's not broke, we don't touch it when we go to the race. But of course, other parts of the organization are quite different. And if we go right back up to the other end, the concept, the aerodynamics end, we are in a very different position. My background was in aerodynamics, and I'm used to the fact that we, in aerodynamics, we probably get about 5% of what we do actually makes it to the car. So that's a 95% failure rate. But actually, what we're doing, every one of those experiments, every one of those failures, we learn a huge amount from. And it's true to say that when we go to a race and we've had an absolutely overwhelming 1-2, we've gone off in the distance and we're there giving each other high fives, clapping our backs, whatever it is, you get a good feeling. But actually, it's the race where you have the disaster, where you burnt the tires out, where you had a failure, that's when you actually learn. And so our business is about taking risk, allowing people to take making those mistakes, because every time you make a mistake, every failure gives you another little piece in the jigsaw of understanding, and you keep building up that level of understanding. So, how to innovate? The thing we've learnt is you've got to give people to innovate. There is the terror of the day job all the time, where the siren voices of the problem today is really overwhelming the calls from things you need to deal with tomorrow. So we did an experiment a couple of years ago in our aerodynamics group. We took the 80 or so engineers in our aerodynamics group, and we said, right, half a day a week, happens to be Tuesday afternoon, you're not allowed to do your day job. We encouraged them to go off and investigate, research, anything that was of interest. Didn't have to be directly connected with a racing car. They had to come back and present it to their peers. We also asked them to look at little projects, little innovation projects, things that were difficult, little pain points, and come and make sure these projects could be delivered within a few weeks, just a little step. So what did we learn from this, our set-aside experiment? Well, we'd taken 10% of resource away, so there's clearly going to be some effect. The effect was a lot more innovation, a lot more accumulation of innovation. But the other effect was our performance trackers all started increasing faster. We were doing less work and getting faster. And this really opened our eyes, and we've tried to extend this throughout, where possible, the rest of the organization. But certainly everybody in the organization now, whether they're shop floor, management, everybody has the concept of performance development, of capability development in their individual objectives. Now it's clear that innovation in our organization, it filters up from underneath. It's not imposed from on top. The role of us senior people is to try and nurture that, to try and give the right environment, to give the space to take the risk, to deal with the failures, and support that innovation. So, given all this, why are we starting our digital transformation program? Why, for a company that's got decades of investment in data, immersed in data, it's our lifeblood, why do we think we need to really focus on a digital transformation? Well, I think there are two main drivers. We need to improve our rate of development. We need bigger steps of performance. We need to find bigger steps. We need to find them more often. We need to bring those performance steps to the track faster, or preferably both. We also are seeing that as we've grown and as the challenge has grown, that communication and information challenge has got bigger. Now, we're very dependent on our experts, on our specialist skills that we have. And one of the things we need to do is we need to capture that. We need to capture those individual skills, and we need to save those for the long-term security of the organization. And we need to make that information, that knowledge, available to the other members of the team. We also need to be able to make that information available to people that join the team, so that as we onboard people, they're immediately able to see they have a very short learning curve. They can get right up to speed with what we're doing. So we try and make the knowledge available to everybody. And we're not really, I shouldn't say this probably, but we're not particularly resource limited. We're very well supported. But we can always take any efficiency improvement and turn that into more performance. So we're reinventing our strategies for our investments in people, process, and technology. In other words, digital transformation. We're doing this in a much more structured way. We've made investments in enterprise architecture capabilities to really try to understand our processes, to really try and compare what we think we do with what we actually do, and then probably what we should do, and try and work out what we need to do in future and how we're going to use the new technology. And we want to ensure that we've got a strategy that is really properly aligned with our intent. Our Formula One's team's real strength, I think, is the speed at which we can react, the speed at which we can take a problem, we can find a solution, we can implement technology. And our ability really is to take technology from bench level, from bench top, and get it working in the field. We're not a leading edge business, but we are very good at taking technology that's just ready and sort of holding its hand, I like to think, and getting it into the field. And so our next challenge is to apply that ability, that rapid implementation, and apply that into redefining our processes and bringing the whole team with us to exploit those new technologies and ensure that we change the way we work in an effective way. So, for many years, Formula One and the automotive, the OEM world have They've had a slightly uncomfortable relationship, clearly very important marketing benefits from the OEMs being involved in Formula One, but the technology of Formula One being largely aerospace and not suitable for mass production has made technology transfer quite limited. However, we're starting to see some changes, some big changes, which is over the last 10 years, the pressures on the OEMs to reduce their cycle times, to the restrictions and cost control on testing, have sort of aligned with our regulatory imposed restrictions on testing and the level of performance challenge. And it's pushed both of us into very much the virtual world of design and simulation. And what we're seeing is quite interesting, is this alignment of tool sets. Quite different problems. We have an expert driver in Lewis Hamilton. Road cars, to be honest, they've got to be safe when driven by the almost incompetent. So it's a different in business. So different problems, but we're seeing very, very similar tool sets. And we notice this clearly in our R&D programs that we run with our parent company, Daimler in Stuttgart, and Daimler R&D. The next step we've seen is that we're seeing throughout many sectors of business, the realization of these companies that they have data and there's interesting things they can do with that data is bringing us into alignment with Formula One, which is very aware of its data, but wants to do more of its data. And so what we're seeing now is even more alignment between completely different industry sectors, because we're all now starting to focus on this technology of data. And with partners such as TIBCO, we're moving quickly to investigate and exploit these new technologies. We're already using a lot of technologies like image recognition, but we're also starting to apply these technologies to race strategy, failure analysis, data harvesting, really looking into data, looking into the patterns of data to try and understand way better. So we're exploring machine learning, data analytics, other AI technologies. And the other advantage we can give with these partnerships and these interactions with other industry sectors is really to share our skills of the ability to onboard technologies very quickly and show the benefits of the sort of Formula One approach to technology change. So we're back to where we were with our objective, winning multiple world championships. This is a close-up of the trophy, the Constructors' Championship trophy. This is what motivates us all. And 2014, 15, 16, and 17 won by Mercedes-AMG Petronas. And it's neck and neck this year. Formula One thrives on challenge, on new technology and the pressures that come from that. And I think it's true to say for all of us that success is going to come to the people that are able to deal with the changes most effectively. Managing change, embracing change, and incorporating change will be your key to success. Thank you very much for all your attention.
Thank you, Jeff. Thank you so much for coming.
It's a pleasure.
And especially for us, and fly back straight to the UK. All the best to the team.
Thank you very much.
It's a close championship. Great race indeed in Monza. So all the best and happy.
Thank you very much.
Proud of the partnership. Thank you.
Right, goodbye.
Yeah, please, another round of applause. Jeff.